Saxon's Calculus Lesson 109 is about polar equations and polar graphing. Now the issue here is that it is much more helpful to have a graphing calculator to do these. They are very time consuming when tried to be done on paper. So I opted to not cover lesson 109 on the polar graphing. You are welcome to look through it. The shapes that they make blow my mind and they're absolutely fascinating. But as far as us doing the manipulations, we're not going to. But please, by all means, feel free to read through lesson 109 if it interests you. Now, lesson 110 is about partial fractions, and there are 3 of these in the last lessons. Because I doubted that we would actually cover this far into the book, and also just because I was making a judgment call, I chose not to do the partial fractions. Again, it's interesting. It is about working through with your algebra steps, just as you are used to doing, but covering up pieces of it with your finger and working through the other parts. Again, you are welcome to read through lesson 110. Now, lesson 111 is polar graphing a second time. So again, it's being skipped, but interesting to see how they deal with all of their graphing of the shapes. And then lesson 112 is partial fractions a second time. Since I chose not to cover the first one, I'm not covering the second one. And now we reach lesson 113, which is integration by parts for the second time. This one I did choose to cover. So jumping to example 1, we are finding the integration of x squared times the cosine of 3x dx. And because it was integration by parts, that was my big clue that I was supposed to be splitting it up into its pieces. So the u was x squared, and then the opposite corner, the dv, is this part, cosine x dx. Working backwards, gets me to v had to be, and to remove the 3, 1/3, and then cosine goes to sine of 3x. And then I also had to do the derivative of the x squared, which got me to 2x dx. Now, once I'm here, you need to remember the formula, which is uv minus the integration of v du. So I've written u x squared times the v, which was 1/3 sine of 3x, minus the integration of, and here's v rewritten, and the du with the 2x dx. Okay, so then I rewrite this part and I put it on hold, because what I realize when I get to here is that I still have I'll do a simplification. 1/3 and the 2 makes 2/3 as a constant pulled to the front. That leaves me with x and sine of 3x. Well, I still have a problem of 2 pieces multiplying. That means I go back to a second box, and this is why it's part 2. So the u is the x, the dv is the sine of 3x dx. Working backwards, that goes to get rid of the 3, sine negative to negative cosine. So that goes to negative 1/3 cosine of 3x. Deriving x gives me 1 dx, so du equals dx. And now I'm following the same formula of uv. So here was my x multiplying here, so negative 1/3 x within the cosine of 3x minus the integration of v du. V is rewritten, and then du is just dx. Okay, so now I rewrote this part, and then I was working on the integration here. So the 1/3 acted as a constant, pulling out it was negative, so that changed it to plus 1/3, leaving the integration of cosine of 3x. So I obviously do that and get it to sine of 3x, and then how do I get rid of the 3 that was created? Well, I put it 1/3, but there was already a 1/3 in front as the constant, so 1/3 and 1/3, and I didn't write it here. I jumped to simplifying the answer, and then I realized, wait a minute, maybe you need to see where that came from. So skip from this step down to this step for a second. This made the 1/9 sine of 3x. So now I'm pulling back from the front, x squared over the 3 sine of 3x minus, and then I jumped down to my 2/3 was pulled out, and then what was the answer that I got there? The minus 1/3 x cosine of 3x, and then as I already said, that plus 1/9 sine of 3x. Okay, so then I simplified that into the box that I was doing. So this became x squared over 3 sine of 3x, no change. And the negative 2/3 was affecting these two pieces. So negative times negative made it positive, and that makes it 2/9 with the x, cosine of 3x. And then the negative with the positive made it negative 2 over top of the 27, and then the sine of 3x, and obviously we have a plus c at the end. Alrighty, now that you kind of get the idea, example 2 said integrate e to the x sine x dx. So once again, break the box down. The first part was u was e to the x, dv was the sine x dx. Working backwards to the v gets me negative cosine of x. Deriving gets me e to the x dx. Following u times v, ex, so negative ex cosine x. And it's supposed to be minus, and you'll see why it's not in a split second, minus the integration of v du. Well, that was a negative pulling to the front as a constant. That's why I changed it to a plus. Integration of, and then I was clarifying, yeah, it's a positive, e to the x with cosine of x dx. So it's just those parts kind of simplified together. Now this time, rather than holding it and waiting to bring it in at the end, I thought it just might be easier to kind of keep flowing it down with me. So negative e to the x cosine of x, I left there. Now we are doing the, just a second, did I just derail where I was? No, I dropped that part down. Yes. Okay. So then I was trying to then integrate this e to the x cosine of x. That had multiple parts. So again, my second box, u goes to the first part, the e to the x, and then dv is the cosine of x dx. Working backwards, that takes me to sine x. Deriving this one takes me to ex dx. Okay. So now this is this part dropped down, and then we're doing u times v. So the plus dropped down, ex sine x, uv, minus the integration of v du, so that's the ex with the sine x and the dx. All right, and since I'm now down to an integration of a multiplication, I'm going to end up following the 1d2 plus 2d1. So this is the first part rewritten, this is this uv part of this one rewritten, and now we're down at this minus, which is dropped down. Okay, so 1 is e to the x, derivative of sine goes to cosine, plus second one is sine x, derivative of first one, e to the x is e to the x, and then we have, of course, the plus c at the end. But this can be simplified, so let's do that. Negative e to the x cosine of x and negative e to the x cosine of x is actually negative 2 e to the x cosine of x, but I need to fix it so it's not there when I work the problem. So remember that it goes to negative 1/2 e to the x cosine of x. Now I have the same thing here, e to the x sine x with another e to the x sine x is 2 of them, so I make it plus 1/2 e to the x sine x with my final plus c. Okay, now example 3 asks us to integrate, e to the x cosine of x dx. Now in this one, I did the box as I have been doing in the other examples. However, they wanted to show you that if you swapped the u and the dv, you could do that. I just kept it going with what I had done. So if you want to follow what the book did, you're going to swap them. So I said that the u was still e to the x and the dv was cosine x dx. What they did was said u is cosine of x and dv is ex dx. All right, anyway, it will still work the same. Now you can tell that I was having some massive issues with signs as I worked, but going this direction, uv is ex with my sine x minus the integration of v du, so that's the ex with the sine x and the dx. Then I had to, again, too many parts, so I had second box. And again, I kept it, u was the e to the x, dv was the sine x dx, working backwards to negative cosine, deriving down to ex dx again. So now I rewrote the first part here, and this was a minus. I'll try to walk through why I had trouble with the signs. Then I am following the formula u times v, and it was a negative, and so it should have been a positive, and I don't know why I second guessed myself, but anyway, I'd started it as a positive. It is positive. All right, and that's e to the x with then cosine of x minus the integration of v du. So that's a negative e to the x cosine of x dx. Okay, so then I rewrote the first part, had to fix my boo-booed sign. Okay, and then I'm here with this integration. So again, I have to follow 1d2 plus 2d1. So the first one is the negative e to the x. So the negative is acting as a constant and pulling out and making this negative positive. Derivative of cosine goes to sine. And then I have my 1d2 plus 2. So my cosine of x and the derivative of e to the x was e to the x. Now technically it's negative, however this negative distributes in there and still makes it plus. So it gets to be positive no matter which way you do it. Okay, now summarizing, e to the x sine x, e to the x sine x, again that's two of them, so 1/2 e to the x sine x to fix it, and the same thing happening with e to the x cosines, so 1/2 e to the x cosine x plus c, just like you saw in the last example, working exactly the same way. Now again, it's fascinating to see how they did it backwards, but you do still get to the same place.